Hello friends, this video by DEW Journal Live explores the Bengal Fan, a giant underwater sedimentary basin with immense sediment thickness, organic-rich deposits and scent-filled channels, making it a promising region for undertaking and evaluating its oil and gas potential. The Bengal Fan represents an emerging frontier in the study of India's offshore hydrocarbon resources. With this in mind, I invited Dr. Sandip Kumar Roy, a distinguished exploration geologist and AAPG certified petroleum geologist, to share his insights on the hydrocarbon potentials of the Bengal Fan, India. In this talk, he shares evidences, analysis, and informed opinion while avoiding overstated conclusions. Dr. Roy brings extensive knowledge and experience from the oil and gas industry with broad exposure to the geology of the Andaman Basin and several other Indian and international sedimentary basins. He holds a PhD in process sedimentology of the Andaman Flysch from IIT Mumbai and served ONGC for over 2 decades, followed by professional assignments with BG UK, Petra Energy Brazil, Petronas Malaysia, and the Directorate General of Hydrocarbons, Ministry of Petroleum Natural Gas, Government of India. Dr. Roy has authored several research papers on basin tectonics and sedimentation and has presented his work at numerous international conferences. He also guides MTech students at the Central University in India and is a member of AAPG, SPE, IAS, GSM, and GSI. Dr. Roy has been a valued friend of DEW Journal, and it's my pleasure to present his valuable insights into the hydrocarbon potential of the Bengal Fan. Over to you, Dr. Roy.
Thank you, Mr. Arun Singhal, Sir, editor of DEW Journal, for asking this pertinent question as to what would be the hydrocarbon potential of the Bengal Fan. This question has great relevance in view of the deep water targeting that India is approaching in different sedimentary basins of east and west coast and also in Andamans. Now, the Bengal Fan, it is the largest deep sea fan in the world, and it has a length of around 3,000 kilometers and width of around 1,000 kilometers north to south. It has a depth of 16 kilometers closer to the shelf edge, and it has 3 positions: the upper fan, mid fan, and the lower fan. In the upper fan, it will be around 16 kilometers in thickness. In mid fan, it will be around 12 kilometers, and in the lower fan, it will be less than that. The point is to say whether the Bengal Fan has potential or is totally trash. It would be very, very preposterous to say at this point of time. But at the same time, let us have a look at it from the geological standpoint. The first point we need to say is we can divide it into the eastern sector, the central sector, and the western sector. In the eastern sector, when the Bengal Fan approaches the Rakhine Basin, which is offshore Myanmar, there the published data shows us very muddy systems of very small fans, of thin channels and very small fans. And it is a muddy system. Very good further south, it meets the Andaman Basin, where the Indian plate is subducting beneath the Eurasian plate. And the Bengal Fan from the Indian plate gets accreted to the subduction zone of the Andaman Basin in the Eurasian plate. But there again the system is muddy, although some carbonates are there. Now, in the Bay of Bengal, there are 2 major geomorphic ridges, volcanic ridges, the 90-degree east ridge and the 85-degree east ridge. Now, when the Bengal Fan in the eastern side approaches the 90-degree east ridge, it segregates into the Nicobar Fan on the eastern side and the Bengal Fan on the central side. The Nicobar Fan again is supposed to be muddy as viewed from the seismic data interpretation. Now, if the eastern side is so muddy, where is all the sandstone? That is the fundamental question, where 2 major river systems, the Ganga and the Brahmaputra, are coalescing to form the Meghna and coming into the Bengal Delta, into the swatch of low ground where very sharp V-shaped channels enter into the deep water. Now coming to the western sector, the Bengal Fan first hits the Mahanadi Basin, then the Krishna Godavari, and then of course the Kaveri. But the major influence is on the Mahanadi. If we have a look at the seismic profiles in the Mahanadi, we find that the 85-degree switch is interfering with the sedimentation which is happening. And there, during the early Eocene time, when there is a major unconformity or the soft collision of the Indian plate against the Eurasian plate, at that time, the west of the Bengal, the west of the 85-degree switch, the sedimentary thicknesses of contribution coming in from possible Proto-Bengal Fan was very, very thin. Towards the east, it is much, much more thicker. But in the hard collision in mid-Miocene time, around 15 million years, where the Bengal Fan has interfered a lot with the sedimentation in the Mahanadi Basin, the waters of Mahanadi Basin. And the question that we need to ask ourselves is, how much is the external controls or extra-basinal controls of the Bengal Fan on the Mahanadi Basin and the Krishna Godavari Basin during Miocene and Younger times? How much of this sedimentation has actually reached the closer shores where the continental crust will be there and the heat flux will be greater, where the cooking of the hydrocarbons can also happen along with the reservoir walls. Now, some of the published papers which we have seen in the inner fan, which is close to your shelf, there again we have seen very, very narrow or in width your meandering channel systems, which does not augur well. And the channels are very, very thin in width, which again doesn't augur well for the science. So the point is, has the science reached the Mahanadi and the Krishna Godavari? They must have reached, but we do not have concrete data to say that at the moment. Needs more interpretation. So coming to the central sector, that is the core sector where most of the science might have gone. And that we can see from the seismic interpretation of Pleistocene section by some Chinese authors, where they have shown that there are major channel levee systems coming in, which are switching channels this way, that way. At least 3 to 4 major switch channel systems there, which are going into the deep waters. Now, there the V-shaped, very strong V-shaped valleys of channels along with large levees are there, but we should also get splays, turbidite sheets and things like that in the central part. So the central part is the key area where the exploration can happen. And what is important is, besides the Pleistocene, whether we can go into the late Miocene and the mid-Miocene times to check out how much reservoirs are there and stuff like that. In terms of hydrocarbon entrapment, I think up-dip pinch-out systems of the Bengal Fan would be very important. And these up-dip pinch-outs can be stratigraphic, or they can be against unconformities, they can be against faults as well, so it can be structural as well. So that is what is going to hold the key. As we get closer to the shelf systems, there the debris flows will count, where coarser sediments which are coming hurling down the shelf slope will matter. And as we go into the mid-fan, there are chances that the channels will go into the submarine fans, and we can have more well-sorted medium to fine grained sands of large areas which can serve. One thing we should remember, that these deep water fans, they are self-contained petroleum systems, because otherwise, how would Markham Delta deep water and how would the Gulf of Mexico produce so much hydrocarbons? Actually, what happens is, during the low stand of sea level, the incised valley fills, they carry all the organic matter from the shelf into the deep water in buttons. And I have seen myself from field work in Malaysia as well as in the Andaman Basin in India, that the levee systems, sometimes they're organically very, very rich. I have seen thin gold streaks also within the sand-rich reservoirs of Andaman fish in the Andaman Basin. So it is possible that they are well charged by themselves. They have got the reservoir, they have got the source, and the trapeze scenes has to be there. So, so that's all for now. So I must thank Mr. Arun Singhal for asking this very pertinent question about the hydrocarbon potential of the Bengal fan. Let us keep our fingers crossed. And how about keeping the thought processes in mind about the central axis of the Bengal fan as a potential area for exploration? Thank you.